Good morning, fourth grade online learners. Today is February 16th, 2021, and yes, I'm wearing long sleeves. It's cold out there. It doesn't just look cold, it is cold. So welcome to science class, Mr. Monzo, me. We are starting a new lesson today, and if you're curious, there was no work yesterday. It was a free day for kids, and I was here learning about new science, and we're looking at two different science series and maybe a third one tomorrow. And hopefully we get to pick one of those three and we have some more updated and exciting science for next year. I'm thinking that's when it's going to take place. And I have my computer on Nathan's desk, so I'm going to ask Nathan, try not to kick the desk because it looks like there's a small earthquake when you do that. So yesterday, no work, online learners. Today, we are going to read about mixtures and solutions in the book. And we are on page E54 if you have your book at home. And there's only two journal entries this week. One tomorrow, one Thursday, and then the quiz. Study guide is online. One of the good things I'm noticing about these new science series, both of them, and then looking at the third one tomorrow, they have the books online. So if you're at home, you don't need this. So let's hope. There's one that I really like, guys. It has a lot of exciting stuff, and I hope that's the one we pick. But we'll see. We have to look at one more for tomorrow. Okay, but for today, we're talking about mixtures and solutions, and a boy that's entirely too happy about using a magnet. Yeah, he should not be having this much fun. But anyway. Mixtures and solutions are made up of two or more substances that are combined in a physical change. What's at the bottom of your backpack? Maybe you have a combination of broken pencils, erasers, paper clips, and scraps of paper. That sounds like mine. This combination of things is a mixture. A mixture is a matter made up of two or more substances that are combined physically. Making a mixture is a physical change. Although the pencils, erasers, paper clips, and scraps of paper are all mixed up, their physical properties have not changed. The pencils are still pencils. The paper clips are still paper clips. So sometimes when you have a mixture, guys, well, all the time when you have a mixture, and Nathan, you have to remember to stay still because you're still creating a lot of motion on your desk.
Why?
Sit still.
Okay.
Thank you. Okay, so just because you mix things up doesn't mean a pencil turned into an eraser or an eraser turned into a paper clip. You could take those things.
Kevin, can you please come to the office, Kevin?
I'm working here, Kevin. Okay, you could take that paper clip out of the mixture and it's still a paper clip. It didn't turn into anything. Okay? So this mixture of iron filings and sand is easy to separate using a magnet because making a mixture is a physical change. The parts of the mixture keep their properties. So yes, young boy who may need a hobby. He is pretty smart though. He's using a magnet to get the things that are metal away from the things that are not. Okay, so on the next page we're going to talk about soup and coins.
Money.
You can easily separate the mixture at the bottom of your backpack by using differences in physical properties. The more different the properties of the parts are, the easier it is to separate the parts. Separating the parts of the mixture is also a physical change. Not all mixtures can be separated by hand. Some mixtures can be separated using a change in state. To separate a mixture of sugar and water, you could boil it. The water would change to a gas, leaving the sugar behind. Differences in density can also be used to separate a mixture. Remember that like mass and volume, density is a physical property of matter. A sample of soil can be divided into parts by mixing it with water and allowing the mixture to settle. The most dense parts sink first. The least dense parts sink later. The soil might divide into a dense layer of small stones at the bottom, followed by a layer of sand, and then a layer of clay with the water at the top. So as far as the soup on this page, what physical properties of the parts of mixture are being used to separate it? Well, we can answer that by saying water. Water and pasta are being separated by their different state, a solid and a liquid. In the coin machine, what is the main idea here? Well, we're trying to say that combining the parts of a mixture or a solution is a physical change. This device can separate a mixture of coins according to their size. Now, somebody very smart, guys, invented a machine that if you go into Giant Eagle, you can put all your coins in there, and let's say you put $10 worth of coins into this machine, it'll give you a receipt, and you go to the cashier and she'll give you dollar bills. But it does charge you a little bit. Let's say you put $10 in there, that machine might charge you 50 cents just to organize it. But it's a quick, easy way to say, here, I have a bunch of change. I want to change it into dollars. Nathan.
Okay, what happens if you put your money in, but it's less than $1?
If you put your money in and it's less than $1, well, I'm just checking the time, Nathan. That's probably not a good idea. Unless, remember about kicking the desk because you're still shaking the screen. So just try to keep your feet still. Unless you have 70, or let's say you have 80 cents in pennies. You could throw it in there and it might give you 5 quarters back, and it might keep 5 cents charge you. It charges you less for the less amount of money you put in there. So instead of walking around with 80 pennies in your pocket, you could have 3 quarters. Hey, that cost me 5 cents. Or you can get one of those machines and do it yourself, like on the previous page. Nicholas.
Oh, it's about the density. It's like how oil's at the bottom and water's at the top.
Very good. So density, sometimes if you're using liquids, you can say oil's at the bottom, water's at the top. Same thing with these mixtures, guys. They're going to separate themselves. Not always. I mean, if you have a solution, that's different. But a mixture will separate itself. Some common mixtures. Here's some bubbles. When you last blew bubbles, did you know that you were playing with a mixture? Look around. You will find mixtures everywhere. The water you drink has minerals mixed up in it. A bowl of soup and a glass of milk are both mixtures. A trombone is made of brass, a mixture of metals. Your drawer full of socks is a mixture, and so is a bag of trail mix. Mixtures can be any combination of matter. They can be combinations of solids only, liquids only, gases only, or a combination of any of the three. In some mixtures, like soup, it is easy to see the separate parts. Not every spoonful of soup is the same. Some spoonfuls might have many carrots. Other spoonfuls might have only noodles. It is easy to see that separate parts of soup have not lost their physical properties. In other mixtures, you cannot see the separate parts. In lemonade, you cannot see the water, lemon juice, and sugar that make up the mixture. Every sip of lemonade has the same taste. One sip is not sweeter than the other. Although it is not easy to see, the separate parts of lemonade still have their own physical properties. I'm going to do a time check here, and we're at 8 minutes. So let's see. I'm going to do one more page, and we'll save the rest for tomorrow. Look at the mixtures in this lighthouse scene. Some mixtures are easier to see than others. You might have guessed that fog is a mixture of air and water. Air is a mixture of gases. Another mixture you might recognize is seawater. Seawater is a mixture of water and salts. Rock is a mixture of minerals. The lighthouse is made of many different mixtures. Concrete is a mixture of gravel, sand, limestone, clay, and water. The glass and the metal that make up the light are both mixtures. Even the paint on the lighthouse is a mixture. Okay, so fog is a mixture of air and water. Air is a mixture of gases, including nitrogen, oxygen, and carbon dioxide. Okay, and there's also there's a glittery wand there, and it says you can see the mixture of glitter inside the wand. Okay, 4th grade online learners, we're going to take a break because we are right around the 10-minute mark, and so let's just give you a couple reminders. We were off on Monday, free day, nothing to do. Today, you listen to a brief lecture burst on mixtures, nothing else to do. Wednesday, journal entry. Thursday, journal entry. Thursday, use your study guide to get ready for the quiz. And Friday, there's a quiz. So there's only 2 points for journal entries this week. All right, 4th grade online learners, make us proud. Do a good job. And we will see you tomorrow. Everybody say goodbye.